Okay, so, yeah. Are we ready? Let's go. So, what we're going to do is consider, one, two, or possibly even three functions. I can't see my ruler around here. We have to draw my groovy little function machine. Oh, there it is. Yeah. So I just want to draw a little function machine here. What I want to do is I want to have a combination of these functions. So I'm going to put, like say, a number or anything I like into one machine, and then I'm going to put it into a second machine and see what comes out. And then ask ourselves, can we write a machine that does those two steps in one? Okay, so let's just do the first one. How will I do this? Oh no, I'll do it as a vertical kind of drop. So let's just pretend that here's one function machine here. And here's another function machine here. Yeah, well, and let's draw our little tube things. There's my input bit. I'm going to draw my output bit like this so it's different. And then I'll draw my input bit here. And here's my output bit there. Yeah. So this is kind of my machine. Let's start with this one here where let's say it goes through the F machine, which is x plus 1 first. And then after going through the x plus 1 machine, which is F machine, or I might write like that, there's the F machine there. F machine is x plus 1. And my G machine does x squared minus x. So let's throw some numbers into this machine. So let's just throw in the number 1 to start off with. Yay!
Yes!
1 goes into F, what comes out the other end, Zainab?
1 goes into F, and what comes out the other end?
Girl, it's 1.
Oh.
Wait, is it not 1?
Well, this is F, so if I put...
G, okay.
Yeah, so if I put 1 in for X, what comes out the other...
2.
For F? Great, the number 2 comes out. Yay! Well, I need to put a little break in there, don't I? So the number 2 comes out and falls into the G machine. Yeah? Petra, what comes out of the G machine there for?
4 minus 2.
Yeah, 2 squared is 4. Well done. Minus 2 is 2. Excellent. Does everyone see how that works?
Yeah.
And then my 2 comes out. Is there a function that can do those 2 steps as one?
Yes.
Yeah.
Yeah, and that's what I call my composite function. Right. So I need a function that does that. So what would you do? How would you do that, do you think, Charlie?
You put g of x is the x value of f of x.
Yeah, so basically I've got to put, well, I would put f in this case has got to go into g, isn't it? Yeah? So really, what we're saying here is, yeah, just hang on, just for a bit. So what we're saying here is x then goes into f, and then f then goes into g.
Thanks for the goal.
Very, very good. So there's one way to say that is that we can say like this, and it's a little bit tricky. We actually have to write this backwards, if you like. So in other words, we write this as g of f of x. That's one way to write it.
Go fast.
Another way to write it is to do actually what we're doing. We're substituting into g of x, f of x. So when I was your age, I used to hate that bit. But of course it's much easier. All what you've got to do is, it reads this way, but how does it really work? It works in the opposite direction. Does that make sense? So really what we're physically doing in this machine is we're actually going this way. So x goes into f. Say, Nate, just stop talking. You can talk after at recess or on the holiday. Yeah, x goes into f, and then that whole thing goes into g. So we read it that we actually operate it that way, but we write it that way. The way I used to like to write it, unfortunately that's the most likely way it's going to be on your exam. Yeah? The way I like it written is, really all what we're doing is f of x is being substituted into g of x. Sorry, yeah, f of x goes into g of x, yes.
So in like composite functions, is it always f that goes into g, or can it sometimes
Yeah,
be?
no, it can be anything, and we'll look at all of those different ways today. The easiest way to think about it though is you've got to apply the machine, if you like. X goes into f and then f goes into g. You've got to read it backwards, even though we write it this way.
Yeah.
Even though your eye kind of reads from left to right, what's actually happening physically is you're actually going backwards. So that's one way how we can make our composite machine. So by making our composite machine, all what I've got to do is put f of x into g. So to do that, I'll write g of f of x means for every x in g, I've got to place f in there. Okay, so this now will become x plus 1 squared minus x plus 1. Does everyone see that? I've put in, and I'll just draw this for you, I've put in f of x here has gone into x, and it's also gone into that x there. And then we end up with our composite machine. So our composite machine is going to be x squared plus 2x plus 1, I've just expanded that, minus x minus 1. Don't forget to distribute that negative to there as well. So our composite machine will be x squared plus 1, and that, oh, x squared plus x, isn't it? Plus 1x. Yeah, agree?
Why is it minus in the middle if g is x squared minus x?
Well, because I've put in, well, here's f here, and
That's
there's
it.
f there, and that's the minus. So I've got to put x plus 1 in for x.
Oh, okay.
And
Yeah.
then I've got to put
yeah.
x plus 1 in for x there.
Yeah. Okay.
Okay, let's see whether this new composite machine does what the other two machines did. So basically what we're trying to do is make up this bigger composite machine. Here's my composite machine. Here's my composite machine here. Let's see whether this actually does the same thing. And we'll test it out with a few values.
That sounds good.
So what's my new composite machine? We think our new composite machine, which is g of f of x, or another way, well, look, I'll be honest, the probably way they'll write this on the exam is like this, g of f of x, and they won't put the third of, the second of in there. That's probably the most likely way that they write it, but really, it could be written like that. 3 different ways it could be written. What do I think is the most common way it's going to be written? I think this is the most common way here. Yeah. The second most common way is probably that one there, and I don't think you'll get that one at all. No one really writes the of there. But really that's what's happening, isn't it? X is actually going into f, and then that f of x then goes into g. So that's probably the technically way that you should write it, but these are the other 2 ways that we do it. So here's my composite machine, which is x squared plus x. Now, what should happen in this case is, what if we put the number 1 in? What should we get out? Yeah, we should end up with 2. Does that work? Yes. 1 squared is 1, plus another 1 is 2, and 2's coming out. So yeah, my composite machine works for that. Let's just try another number, just to make sure that we know that's going to work. I'm going to substitute in, yeah, let's put 3 in, why not? 3.
Mr. Stewart.
Yep.
The answer for g of f of x, does it say x squared plus x, or is it x squared plus 2x?
Well, I've got x squared plus 2x, but then I've got to subtract an x squared off. Sorry, Nick. I've got x squared plus 2x, and I've got to subtract x off there, so that'll just make that 1x. I've got
That's
plus
just
1
x, okay.
minus 1. Does that make sense? And it's so let's put 3 in. So 3 comes in here, I get
4.
Yeah, 4 comes out. So yeah, 4's going to come out. 4 goes into this next machine, and what comes out? So 4 squared, 16 minus 4 is 12, and 12's going to come out.
I was really about to say 8.
Yeah. Okay, let's see if that happens here. Let's put 3 into this composite machine and see whether that makes the same thing. 3 goes in.
No.
Let's go. 3 squared is
9.
9, plus another 3 is
4.
beautiful. So we can see how that works.
Yes.
do we have to put F first? Could I swap that over? Well, yeah.
Yeah.
What would that be called if I swapped it over? X. Yeah. So here you've got to go that way, don't you? So it's going to be F of G of X. If I was to do you want me to draw that picture and just have a look at how that works, and then look at what the composite function for that is?
Just look.
Okay. So let me just draw that little machine. Are the machine, those sort of diagrams helping you go through? Does that sort of help? So let's swap it over now. Let's swap over the order of those machines. And I'll put the composite machine right next to it. So that comes in there, comes out, comes in.
You can do it, but you don't need it.
So this time, let's make this G. So G is my first machine, which is x squared minus x. And then F is my second machine, which is x plus 1. And right next to it, let's put our composite machine. Excuse me. Put our composite machine.
Mathematics now.
Yeah.
Just grab my texter here. Let's look at this one here. So again, I'm going to let's put in a number 1. Why not? Put 1 in, what comes out?
2, oh, yeah. 0.
0 comes out. Let's just play around with this. So 1 goes in, 0 comes out. If 0 comes in,
1.
0 goes into this machine,
1.
and the number 1 comes out. Let's put another number in, like 4. Let's put 4 in.
You actually trolling.
4 goes in. 4 squared is
16.
minus another 4.
12.
12 comes out.
Yeah.
12,
13. Oh.
It's going to be 2.
12 goes in.
13.
And
It's going to be 11.
13.
13 comes out.
Yeah, man. Yeah.
It's out. 13's out.
13. Oh.
It's come out.
Why 13?
Let's look at what my composite function is. How do I write my composite function? Yeah, so you got to write it backwards, really, don't you? So we write F. That takes us having a short life.
It's dying.
Goodbye.
Write that over there. I'll pick that up in a moment. This is F of G of X, which we'll write as F of G of X, okay? Yep, so we're actually writing it that way, which is the opposite. Yeah, so really X is going into G, G is going into F. So what do we have to do? We have to put F, G, everything about G needs to go into the X part of F. So let's do that up here. So we've got F of G of X means that I've got to put G into X, so the whole bit of G, which is X squared minus X plus 1. So we have X squared minus X plus 1, that's easy. So that's my F of G of X function. This is X squared minus X plus 1. Let's see whether this works the same as that, and of course it does. Yeah? So what are we doing with composite functions? We're really looking at a situation where X goes into one machine, could go into another machine, could go into another machine, and another machine, and so on. Yeah? So there is a situation where we could put through 3 machines. Yeah? Or we could go through the F machine once, and then go through the F machine, and then go through the G machine. And let's look at those in a moment. So without actually drawing the machines, but let's just check that this works, just because it's a good thing to do. Let's put 1 in here. 1 squared is 1, minus 1 is 0, plus 1 is, 1 comes out. You can see that. Let's put the number 4 in. Number 4 goes in. 4 squared is 16 minus 4 is 12, plus 1 is 13. So this becomes my composite function, or my composite machine, that's able to describe exactly what happens with two machines. So do we really need to write two machines to do that? No. Can I rub this off and let's look at how we might look at three machines?
Yes.
Maybe f of f.
Triple F.
Maybe we should just look at f of f first and g of g first before we go too far. Okay. Has everyone got that? In fact, let's actually do this over here. Can you please see if you can write the functions f of x, yeah, and then see if you can actually write g of x.
Sounds
F of F.
That's tricky, bro.
F of F.
It's like function inception. It's funcception.
Function. X plus Y.
Like write them as.
Yeah, do it. See if you can make up. See if you can tell me what the composite function f of x could be.
And using those values.
Well, using what is my composite function? What is this one function that describes? Because this is really putting x into f, and f goes into f again.
Into the x value of f.
So what I'm going to do is I've got to take f. What's f? I've got to take f and put f into f again.
yeah.
F into F into F.
So f goes into f. Right? So just over here, let me write what f of x is. What's f of x? X plus 1. What I've got to do is put x plus 1 into x plus 1.
It's x.
So maybe it's not a bad idea to write the two functions down and say to yourself, oh hang on, x plus 1 has got to go into
X plus 1.
x plus 1.
So x plus 1 plus 2.
So yeah, that's right. It just becomes x plus 1 goes in plus 1.
That's simple.
So let me write it out how you should. We should go f of x equals to x plus 1 plus 1, which is x plus 2.
Minus x squared plus x plus minus 1.
What happens with this one? What would be a good idea is to write g of x twice
What?
and put g of x into wherever there's. So let's do that one.
x4
G of G.
minus 2x squared.
X squared minus X.
Good job. Legend of the game.
So what I could do is I could put what has to happen. Well, not what I could do. It's what I should do. Is that is g of x. What happens to g of x? G of x has got to go into
G of
g. So I've got to put all of that function
They don't cancel.
wherever there's x in the next function. So I've got to put that. It's got to go in there,
Oh yeah, shit, I'm stupid.
and that has got to go in there.
Yeah,
can you do this?
yeah, you got it.
Is it x4 minus 5?
I don't know. I haven't done it yet, but I'll do
X
it.
to 4
So g of x means I've got to put in x squared minus x all squared minus x squared minus x. Does everyone see what I've done there? In fact, I'm even going to underline g of x so you can really see it clearly.
So it's X fourth.
Yeah, this bit here is g of x, and it's gone into itself.
Oh.
Yeah, g of x has been put into itself. Do I need two functions to do that? Well, you can, and I'll show you how to solve a problem in a sec. Or we can write a composite function, so let's do that. I've got to expand this, so can you do that in your head, or will I actually expand that out? I'll show you.
X4.
I might do it like this, just so you can see. Yeah, now, careful of the negative here, everyone. Agreed? What's a negative times a negative?
Positive.
Plus x there. Don't forget to do that. Let's expand this out here.
X4.
This becomes x times x squared times x squared is
X4.
x to the power of 4 minus x cubed plus x squared minus x squared plus x. That will cancel out, and I'll have that'll equal to x to the power of 4 minus 2x cubed plus x. Now the next bit I really need you to pay attention to, because we're actually getting to the point where I'm going to get you to do some work. Okay, so I might just write up a couple of problems on the board and I'll do them and you can do them as well. But I really need you to pay attention here, just with what I'm about to show you.
This is English, bro.
Literature.
Yeah.
Wow, I want those notes.
It's about structures on essays.
Will I slow down? Yes. I'll just give you to the 8. Okay, you're right? So I'll just give you up to 22, just to take that down. I just want to show you, some students like to do it one way, and some students like to do what I'm about to do another way. Okay? So really what we're doing here is that we're taking one function and we're putting it into the x values of the next function. Yeah, to make one function. So we don't have to use two. However, despite that bit, some students still really prefer to use two functions. And for instance, they might, well, I did say I'd go up to the 8, so
It's funcception, bro.
oh.
It's funcception.
So Petra, I didn't have any coffee this morning.
You have what?
No, I was feeling a bit dizzy. Oh, I think I'm going to back it off the coffee, so taking your advice.
Are you in coffee rehab?
Yeah.
But if you like charming and you don't properly expand it, you get
They tried to make me go to rehab, and I said, no,
Oh my God.
no.
That's a good song.
Oh my God, this song.
Oh my god.
Try to make me stop drinking coffee. No.
I want a coffee, come on.
I think Antoinette's music's amazing.
Winehouse?
I want a key.
What?
I don't know that you
Amy Winehouse, her music.
listen to sing myself.
Wait, are you?
I want a key. I want a key.
Pretty sure.
Okay, everyone. It's now time to move on. Now,
Let's go.
can we all just really just pay attention to this thing? There are two ways that you can do this, and I don't really mind which way that you do it. If I was to ask you this, G, and I'll do this, G of, let's say, 3.
Huh?
No, let's put a minus in there because it's always a little bit harder.
Yes.
Come on.
If I asked you to do G of minus 2. Now, let's just remind ourselves what G of x is. G of x is equal to x squared minus x. Some students like to take the actual machine way. What is this actually saying? It's saying minus 2 goes into G. Yeah, get that number, and then what do you do with that number?
Put it into G.
into G again. Some students go, oh, sweet, that's just easy for me to do. And I reckon sometimes that's actually the best way to do it. No need to find the composite function, because that's a lot of work to find it if you haven't been asked how to do it, agreed?
Yeah.
So there's two ways. One, you can actually do it like I did with the two machines and just get the number at the bottom. Or you can make that machine, which takes a bit of time, doesn't it? And then put the number minus 2 in. Do you agree? So it's up to you when you look at a problem to decide what to do. But a lot of students just say to themselves, well, actually, all what this is asking me is I go G of minus 2. So what do I have to do? I put 2 into the G machine first, so let's drop 2 into it. Yep, 2 goes in, minus 2 goes in actually.
The G machine.
Just got to be careful with the minuses here, so I'm sort of pleased I've done this.
That's the G
That
machine.
becomes 4 plus 2, thank you. 4 plus 2 is 6. Good. Now what have I got to do to that 6?
Plug it again.
Yeah, just whack it in the G machine again. But you've really got to write this, really, don't you?
Minus
Whack.
Well, I'll just write it like that. 6 goes into G again. So we end up with 6 squared minus 6 is equal to 30. Right. So, look, some students really find that, and there is absolutely nothing wrong with that. Nothing wrong with that at all. What's the other way to do it? Well, the other way to do it is to find what g of x is. So you find what g of x is as a composite function, which is x to the power of 4 minus 2x cubed plus x. That can be a lot of work, can't it? Yeah, and look, some students just do this because that's the way to do it, and I see this all the time. You don't really need to do that. Now what do I have to do if I do it the composite function way is to put the number minus 2 in there. So I've got to actually go g of minus 2 because that's my composite function. So let's put minus 2 in there. Minus 2 to the power of 4. Minus 2 times minus 2 cubed plus minus 2. You'll notice I'm bracketing minus 2 just to remind myself to be careful there. Minus 2 to the power of 4 is 16. Minus 2 cubed is minus 8 times minus 2 is plus 16. And then
Minus 2.
minus 2.
30.
16 and 16 is 32.
30.
Minus 2 is 30. And this, so which one do you prefer? Yeah?
It depends on how long it is.
Well, it depends too how they ask the question. If they ask you to find g of x, and then they say find
The composite function.
find that first, and then find g of 2 or a number or something else, then, but don't forget you can just go back to your simple machine way. Just drop it through the machine, and you'll get the same thing. If you're asked that, you don't need to create a new function, especially if I ask you to find g of f of g of 2.
Oh.
Sometimes you're better off just actually going through all the machines rather than making a function. Students take two different approaches. Please make sure you understand in your mind that if they do give you that number there, sometimes this is just the easiest way. Yet I've seen students make, especially like I'm going to ask that right now, g of f of say minus 1. I could ask that. So let's do it both ways as one practice, and then I might just put up oh, actually, no, we can go straight to a textbook. I don't really want to talk too much more. I could actually talk about one other thing, but I think you should solve a couple of problems. Then I might stop you and talk about how do we think about domain and range of composite functions.
Oh, seriously?
Yeah, seriously, but I don't think they're going to ask that. We don't really know. Yeah, we don't really know if it's going to be asked or not, but I'll just give you one example, and I think that's all I'll do. Yeah, I haven't seen it for many, many years, so the likelihood of it is pretty low. But I still will show you just so you can see that it's not complicated. So let me ask you to do what? Let's go f of g of f. Can you do that? And then I want you to find f of g of f of minus 1 using 2 ways, yeah?
Whoa.
So let's do that. Let me rub this off.
Wait, what was it? F of G?
F, yeah, let's, so if I asked you to find this, I want you to do it both ways. Yeah, so I want you to go f of g of f of x. But what I really want you to find is this. Minus, in fact, let's go for the minus 2 thing again, because that was a good. And can we do it both ways, please? So can we do it dropping through the machine, and can we do it by finding the composite function once? So I'll actually label these as dropping,
What was F of X?
dropping through machine.
What was F of X?
F is x plus 1.
Yeah, let's call that the dropping through machine method. And let's call this, make it the composite function method.
X squared minus 7. I'm sorry.
Shut up, Finn.
I did.
F of G. G of F.
Neve, which one do you prefer? Drop it through? I think everyone prefers drop it through the
Yeah,
machine method,
true.
really.
You're just wrong.
No.
F of G.
Okay, let's see if you can do it both ways.
You're bad.
And let's have a break at 10 o'clock.
No, do it. Do
That
it.
sounds
I'm doing
good.
it.
Yeah,
Let's
let's
let me
go
concentrate.
walk in the sun or something.
It's really hard to do this first question.
Is it?
Just for 5 minutes.
So,
Yeah.
It's 3.
Man.
Can I do it?
I already told you the
F of
answer.
G.
F was x plus 1, wasn't it?
Zero.
Yeah, let me write those down just so we haven't
What are you
forgotten.
doing?
Minus 2 plus 1.
So I'll just write f of x
Negative 1.
is x
Negative
plus
two
1.
is 1
Yeah.
minus 1.
Plus 1. Minus negative 1
What?
is 2. Right? Then
No, I haven't done
2
that.
plus 1 is
No,
3.
I haven't done that part yet.
Huh?
Charlie, why are you explaining it like they're 3?
Wait, how?
2 plus 1 is 3.
Yeah.
Come here. Come here.
So, Anissa, which way do we work with these functions? Do we work that way? No. You got to read it backwards.
First,
Backwards.
x plus
Wait.
1.
F of G.
We do it backwards.
So you work out f.
Yeah, you got to drop it. You got to drop it through the machine that way.
Yeah. Negative.
So let me drop it through the machine.
Is equal to negative 1.
Mm-hmm.
Right?
Let's
Yeah.
Then you
put
have
So-
g
let's
of
put
f.
minus 2 into f.
So then you put negative 1 into g. Of,
F of x is what again?
then you
Oh,
There.
x plus
Yeah,
1.
I've just put those up there for you.
squared minus
3.
negative 1.
Oh, that actually.
I think I got negative 1 on me.
So there's my first one. F of minus 2 is equal to minus 1.
1 plus 1 is 2.
Then I've got to go g of minus 1.
Yeah.
Huh?
Yeah, I've got to
Then
put
you go
minus
F
1 into g now.
of 2.
So
Yeah.
negative 2's gone in, negative 1's come out. Then I've got to put negative 1 into g.
Yeah.
Huh?
Oh, okay. My bad. I
You
was
should
wrong.
thank me, Vita. I just explained the whole thing to you.
I mean,
What?
maybe.
What do you get out the other end?
Wait, give me a second.
2. Now what I've got to do, I've got to put 2 into
Plus 1.
f. Yeah, into f again.
Yes, 2. No.
What's the answer? Oh, I was right.
And as you can see, I've kind of bracketed the bit that goes into x each time. You don't need to do that, but gee, it's nice to kind of just remind yourself with the substitution, isn't it?
You notice how it's 3 not
Yeah.
0?
Yeah, man. I noticed how it's 3 not 0.
Yeah.
Let's make
Yeah.
a composite function. No, yes, we can. Yes. Yeah, we can because what we're going to do is put, first of all, now we've already done what g of x is, but it won't hurt you to do it again.
Yes.
Yeah.
Won't hurt you to put that into there and that into there to make
F of G.
g of f.
That's right.
So I'm just going to make this bit first. That's what I would be doing. So I'll be going g of f of x is equal to x plus 1 all squared minus x plus 1. And I think we did that. What did we get for that? I think we got x squared plus x.
Yeah, X squared plus X.
Now I've got to put that into f. So now this bit here needs to go into f of, so I've got f of g of f of x means I've got to put this bit here back into there to give me x plus 1.
Oh my Jesus, the creator. That-
Now what do I do?
Wait, that's kind of like nice.
Yeah, now what do I do? I just got to substitute in minus 2.
2.
So I just go f of g of f of minus 2 is simply going to be minus 2 squared plus minus 2 plus 1, which is 4 minus 2 plus 1, which should give me, and it
3.
does, oh, thank gosh for that, 3.
Thank you, Bob.
Yeah.
Which god's that?
It's
Which
it's
god?
my god.
Is it
the one,
Gandhi?
the elephant or the...
No, that's no.
Is it Gandhi?
So many cool gods in India, isn't there?
a crime.
India. How many?
Yeah.
It's like the most religiously diverse country on earth, isn't it?
Yeah.
Yeah, it's a pretty cool
I
place.
believe in Gandhi.
Best food on. Beautiful.
Huh?
Ladies and gentlemen,
He's a god.
Yeah, so how do you-
I think it's actually worth us now going to our textbook, and I might work along with you with that. Do you all have your computers?
Yes.
No. Yeah.
Yes.
You can share it if you don't. Do you remember the chapter 4 notes I sent out? Yeah, can we open up that, please?
Oh, is that 442?
Yes.
And just because I've done enough talking on the board, it's really time for you guys to do.
What textbook is that?
That's from last year's one, so you can go and get that out of. But I'll just send it chapter by chapter if you want. It's the same one as that. You can get it from the library.
It's the math textbook.
We may have made a mistake in purchasing that new textbook because the ones last year are still better for A and A than the new ones.
So the
Oh.
mathematical studies is what?
No, the SL, yeah. Yeah, so they are still much better than the new one for SL. But I will send you out those chapters if you want to, or you can go grab a textbook. Yeah. I'm happy if you go grab a textbook. There should be enough there.
Yeah.
Chapter 4.
Yeah, I'll just send it out on Teams.
What page is it?
Yeah, I'll just find it for you,
The
mate.
settings thing about the more options that
Come on, Wi-Fi's bad there. I don't get it. No, free stuff.
it is partially
Mr.
sold.
Stewart, would it be Cambridge or Oxford?
I think it's Cambridge.
Okay.
You are.
No,
Hey? The Wi-Fi's bad.
Okay, ladies and gentlemen, can you please do exercise 4C?
What, 4C?
Is this what your mind was?
4C, it's on page 94.
So disappointed.
94.
Do question 1, please. Question 3.
Sir, can you draw on the board?
See who the people are.
Yeah, so it's 4C.
Yes.
Just all of question 1, please.
All question 1. Okay. F of X.
I knew something about that, wouldn't you?
Squared plus 1.
Yeah, I didn't do any of that.
Yeah, but from that where I was going. Ask yourself like
Because yeah, on the
Man, the Wi-Fi's bad there.
Can we do that now, please, quickly, everyone?
I'm not muffling wherever the map.
Are they doing?
No, I'm not interested. It's
So it's 4C, question 1.
Did I say buck?
Have they started on discrete maths yet?
Charlie, have you got 4C, question 1? Let's quickly do it. I'm going to have a break in 6 minutes, so I think that's all I want to chat for this lesson. I've just got one more thing to show you today and we'll zoom back.
Do you know what the
Cheers. Bye-bye.
question is? Oh, it's here.